Here we go with the last section in this chapter that we're going to deal with. We're going to be skipping section 7 just to make some better progress. So this is the end. We're finishing up the trigonometry, dealing with sine and cosine today. If you understand tangent, then sine and cosine is just one little baby step farther. Not a big deal, really. We already know that, well, if we got a triangle such as this one, if it's a right triangle, and if we're looking at, say, angle A, from angle A's perspective, this would be, let's label it, this would be the opposite side. This would be the adjacent side. Adjacent meaning right next to. And this, of course, opposite the right angle is always the hypotenuse. Let's, for simplicity, abbreviate these as OPP, ADJ, and HYP for opposite, adjacent, and hypotenuse. This is all in relation to angle A. If we were looking at angle B, these two guys would swap roles. If we looked at this angle, then this would become the opposite, this would be the adjacent, but the hypotenuse is always the hypotenuse. What do we have so far? The tangent of angle A is its opposite over the adjacent. Opposite over adjacent. We've probably said that about 20 times by now. Two new definitions. Sine, spelled S-I-N-E, but we have this universal, what's the word I'm looking for? Tradition, there's a better word I can't think of. That a convention, a universal convention here is that we use three-letter abbreviations for all of these trig functions. So we don't write sine, we just write S-I-N, and no, like this is not pronounced tan, this is not pronounced sin. This is tangent, this is sine. The sine of A is defined as the opposite over the hypotenuse. Sine of A is opposite over hypotenuse. You have to remember that. But in the next video I produce, I assume it'll be the next one probably, I will give you a real easy way to remember these definitions. A very easy way to remember them. A way that I continued to use even through college and still use to this day to help me remember these functions because I'm lousy at memorizing stuff. But there's a trick you can use that makes it easy. Some of you maybe already know the trick. So the sine of A is opposite of hypotenuse. Another one, cosine. There's a reason why these are called sine and cosine, but we will not be discussing that reason in this class. We'll wait until pre-calculus to discuss the relationship between sine and cosine. There also is something called cotangent, and there's some others as well that we're not going to be dealing with this year. But like all the others, three letters, we use COS as the abbreviation for cosine. Again, you do not pronounce that cos. No. We pronounce it cosine. So we have cosine of A equals, by definition, adjacent over hypotenuse. But Mr. Peer, what? I don't understand. There's nothing here to understand, really. These are just definitions. You simply have to accept the fact that the definition of sine is opposite over hypotenuse. And the definition of cosine is adjacent over hypotenuse. That's all. They're ratios. Ratios that we generally don't memorize for special angles. We know some of these ratios for 30 and 60 degree angles and for 45s and 45s, but we don't know all the other angles, so we just use these ratios. These are definitions. You have to know these three definitions. There's nothing here to really deeply understand. You simply have to know the definitions. Stare at it, memorize it, and then later I'll show you the trick to help you remember it. That makes it so super easy. All right, so what do we do with all this? Let's apply it right now to an example. This guy. So far we know all about tangent. The tangent of 67 would be equal to 67's opposite over 67's adjacent. But that's not going to do us a whole lot of good if we don't know either one of these numbers. What good is it to us? So forget about tangent. We're not going to use tangent this time. Let's try sine instead. The sine of 67 is what? Sine is defined as, I'll jot it over here. Sine is defined as opposite over hypotenuse. Yes, we finally get to use the hypotenuse. So the sine of 67 is the opposite, which is x, over the hypotenuse, which is always that longest side, opposite the right angle. And there we go. Guess what we do now? Yeah, you can guess. We look up the sine of 67. We go to page 311. We do the same thing we did for tangent, but this time we look in the sine column, not the tangent column. We find the 67-degree angle in the blue column, and that's in the second blue column. We go to 67. Follow along with in your book with me, please, on page 311. Find the 67-degree angle in the blue column, and go one next door to the sine column, and you find out that the sine of 67 is 0.9205. 0.9205. See what I mean when I say if you can do tangent, you can do all these? You can't make these hard. I'm sorry, no matter how hard I try, I can't make these hard. And that's equal to x over 120, so you know what to do next. Multiply by 120, we're done. X is whatever 0.9205 times 120 is, and just sneaking a peek in the book because I don't want to take up all your time doing things on the calculator. Well, I thought I could do this quickly and easily. I can't find the right page. There we go. And they tell us that x ends up being about 110.46. 110.46. But this time, by the way, the instructions kind of fooled us. The instructions tell us to round it to the nearest integer, the nearest whole number. There it is. So this guy next door is less than 5, which means we leave that 110 alone. If it were 5 or higher, we'd bump it up to 111. But it was a 4, so we'd leave it at 110. So x is about 110. We haven't found y yet, though. How do we find y? Same thing, but we've got to be careful. The hardest part of this is deciding, are you going to use tangent, or are you going to use sine, or are you going to use cosine? That's the big deal. Here's my angle. I'm looking for y. I've already found x. Forget about that. We've already got it. From the 67-degree angle's point of view, what is this thing we're looking for? It's the adjacent, right? And this is, of course, always the hypotenuse. Adjacent and hypotenuse. Which function uses adjacent and hypotenuse? Not this one. Not this one. This one uses adjacent and hypotenuse. Which one is it that uses adjacent and hypotenuse? It's cosine. So we're going to use cosine. We have chosen to use cosine of 67 because cosine of 67 is equal to adjacent over hypotenuse. Cosine equals adjacent over hypotenuse. So the cosine of 67 is adjacent over hypotenuse. That's y over 120. I look up the cosine of 67 and I find out the cosine of 67, 67, 67, go over the cosine column, 0.3907. 0.3907, look in your own book and make sure you can see why the cosine of 67 is 0.3907. And that's y over 120. Multiply both sides of the equation by 120 and we're going to get something kind of sort of close to about 60 or so. Let's see what it ends up being. This is example, still example 1. Comes out to be about 47. turns out to be about 47, rounded to the nearest whole number. Okay, next example. This time, okay, we're done now with finding sides. The rest of it, think through on your own. Use the examples in the book if you get stuck. Watch the video again if you get stuck. Now we're looking for the angle. Well, here's our angle. From the relationship of that angle, what is this? This is the opposite, and this guy is always the hypotenuse. Opposite the right angle. So we've got opposite, we've got hypotenuse. We have opposite, we have hypotenuse. We now search through sine, cosine, and tangent and find one that uses opposite and hypotenuse. There's only one. Which one uses opposite and hypotenuse? Nope. There it is, opposite and hypotenuse. We're going to use sine. You see how important it is to have these ratios memorized. Opposite and hypotenuse, we're going to use sine. So back here, we're going to use sine because the sine of my angle, n degrees, is opposite over hypotenuse. It's getting kind of crowded there. So the sine of my unknown n is opposite over hypotenuse. I put this in the calculator, find out what 20 over 40 is equal to, and then I read the table backwards. Sneaking a peek at the book, we are told that 22 over 40 turns out to be 0.5500. 0.5500 approximately is equal to the sine of n. So what do I do now? I go back to page 311. Sorry about the noise, there's a lawnmower outside. I'll just have to yell louder, maybe. Oh my, he's going to pass right by the windows. Let's let him pass. I'm sure he'll be back. Okay, so now I go to the sine column and find the closest answer I can get to 0.5500 in the white sine column, and then read over to see what the angle is. I go back to page 311. I look in the sine column. I find the closest thing to 0.5500, which is 0.5500. Definitely it's closest to 34 degrees, so n must be about 34 degrees. We've got it. We're done. Not so bad. Same story here. Oh no, this is easier actually. This time we're looking for both x and y. I can't use tangent because I don't know either one of these. So what am I going to use? Here's my angle. Let's get x first. What is x? That's the opposite. And here I have the hypotenuse. Who uses opposite and hypotenuse? Yes, you go back here a couple screens and you find out that opposite over hypotenuse is sine. We're going to use sine. So we have sine of my angle, 37, equals opposite over hypotenuse, that's x, over 35. I look up sine of 37. I multiply my answer by 35. I find out what x is, and I'm done. This example came from page 312. It turns out to be, nope, it comes from page, where does this come from? Maybe I just made this one up. I don't know where it came from. I think I took it from, oh I see. It came from page 314, number 1. And x turns out to be about 21. X is 35 times the sine of 37 that you look up, and you get whatever I just said. 21, did I say? Because the instructions didn't ask for the nearest whole number. To find y, we change things up again to find y. Because to find y, we're no longer using the opposite. Now we're using the adjacent and the hypotenuse. Adjacent and hypotenuse. Adjacent and hypotenuse. Where is it? Right here. Adjacent over hypotenuse is cosine. Let's use cosine because I'm dealing now with the adjacent and the hypotenuse, so I will use cosine. The only one that does adjacent and hypotenuse. Adjacent and hypotenuse. Adjacent and hypotenuse, we use cosine. So, I've got cosine of 37 equals adjacent over hypotenuse, that's y over 35. Y over 35. So I look up cosine of 37. Cosine of 37, might as well just quickly look at it because it certainly is not difficult or time consuming to do so. 37 cosine gives me 0.7986. 0.7986. Be sure you can figure out why cosine of 37 is 0.7986 from page 311. Then I just multiply that by 35, and multiplying that by 35, I get a result of about 28. So y turns out to be about 28, and we're done. We move on to my next example. Is this going to be my last example? I don't know, maybe. All right, here's my angle. Let's do x first. X is the what side? All the way on the other side, all the way on the opposite side. Yep, x is the opposite. What's this one called? Not the hypotenuse. That's the hypotenuse. This is the adjacent. I've got opposite, I've got adjacent. Who uses opposite and adjacent? Hey, that's our old friend. Opposite, oops, where is it? Opposite and adjacent. There he is. Opposite and adjacent. That one is our old friend, tangent. So I use tangent this time. There it is. So I'm going to do tangent of the angle equals opposite over adjacent. That's opposite over adjacent. I look up tangent of 50, multiply by 75, I'm done. You want to try that for yourself? You should end up with an answer of, where did I get this example? This was number 3 on page 314. You end up with an answer of 89. X ends up being about 89 to the nearest whole number, the nearest integer. By looking up tangent of 50 and multiplying by 75, it's over. Then to find y, this time, forget about these guys, this time I'm dealing with the hypotenuse, opposite the right angle, the hypotenuse and the adjacent. All right, who does hypotenuse and adjacent? Who does hypotenuse and adjacent? Hypotenuse and adjacent? Nope. Hypotenuse and adjacent? Nope. Hypotenuse and adjacent? There it is. Hypotenuse and adjacent. That's going to be cosine. I will use cosine. So I go back to my problem. I'm going to use cosine of 50 equals adjacent over hypotenuse. Adjacent over hypotenuse. And now, in this case, you might say, hey, can I just switch to the other angle and get that variable out of the denominator? Let's try. If that's 50, what's this? It's 40. All right, let's switch to this one then and try to find y. Forget about x. Let's try to find y on that one. So now what do we have? This is the opposite and the hypotenuse. Opposite and hypotenuse. Opposite and hypotenuse. Opposite and hypotenuse will be opposite, here it is, opposite and hypotenuse. We're going to use sine this time. We're going to use sine, 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 sine. So this time let's try sine of 40 instead of cosine of 50. Sine of 40, opposite, 75, over hypotenuse, which is, oh no, the variable is still in the denominator. What are we going to do? Nothing. I'm afraid with sine and cosine, switching to the other angle will not change anything. But how can these two things that are equal be equal to different things here? Hey, that's the cool thing. You look up the cosine of 50, and then you look up the sine of 40, guess what? They'll be equal. They're the same value. It doesn't matter which one you use. They're both exactly the same. Cosine of 50 and sine of 40 are the same thing. So it doesn't help any. Switching angles won't make a bit of difference. We're stuck with it where it is. We look up cosine of 50. We look up cosine of 50. We look up 50, 50, 50. Cosine, be sure you're in the right column. Cosine column, 0.6428. 0.6428. Please practice doing that before the test. is equal to 75 over y. And now we'll multiply by y. That puts a y over here, and this is now gone. Then we'll divide by this guy, because we're trying to get y by itself. So we divide by 0.6428. We divide by 0.6428. These, of course, cancel. And we find out that y is equal to whatever 75 divided by 0.6428 is. And my book says that one turns out to be, if I can find the right problem, I don't even know where it came from. I got it from the book someplace. Oh, there it is. Okay. It turns out to be about 117. About 117. So y ends up being about 117, and you're done. And I think that's my last example. Yep. So the only thing left to do is for you to try this stuff. This time, you might use sine, you might use cosine, or you might go back to our old friend, tangent. How do you know? It depends on what kind of side you're given. And you lean on tangent equaling opposite over adjacent, sine equaling opposite over hypotenuse, and cosine equaling adjacent over hypotenuse. Lean on those definitions, and you can figure out all these with great ease. Page 314, 1 through 8 all. Please check your odds in the back of the book, but remember, all work must be shown, or your answers are worthless. And I'll send you a nasty message saying, sorry, try again. Okay, all right, that's that. And that also ends the chapter. We're going to have a couple of days of review before the test. So for now, we're done. The end of the glorious chapter 8. Congratulations.